In this lecture, we'll be creating our blockchain address. Right now, I have main.go open, but let's go back to wallet.go. On our right side, this visual may be small and hard to see, but we have these steps and want to install a package that includes these steps. We'll click on Terminal, and I've already written this here, but we'll be using RipeMD 160 and this base 58. So please use GoGet to get these two. I've already done that, so if you haven't, then please do so. We'll be using this, for example, under our import. We have RipeMD 160, and we'll copy this and paste it to import. We have this base 58 down below, and we'll also import this, so copy and paste. From now, we'll write more codes. The font here on the right may be hard to see, so I'll include the steps as a comment. First, we have step 1. We covered private key and public key in one of our previous lectures. This step has already been completed. Regarding our wallet, we'll include blockchain address and create one more field. That means now we have 3 fields. And if you want to make this visually organized, then you could space it out like so. We want to create our blockchain address from now, so I'll copy and paste the steps mentioned on the right as a comment here. I'm going to remove this visual from our screen now, and we won't be referring to this visual anymore. We'll refer to these steps to create our blockchain address. I'm going to scroll down a little bit to make these steps easier to see now. As we mentioned before, we've already done creating our private key here, so now on to step 2. For step 2, it's H2 and SHA-256 new. We're going to be using SHA-256 to create the hash for our public key. We'll write H2 right. If you recall, we had X and Y for our public key. That's why we'll first write X bytes, then copy this line and replace the X with Y. And for our last line here, we'll write nil. This means that a hash will be created for the object up to that point. We'll include digest 2 here. Now on to step number 3. For this too, this will be similar in structure to SHA-256. There's a hash function called RipeMD. We'll write new for this. We'll create a hash based on a result for step 2. So that's why we'll include digest 2 here. The rest is the same as before. We'll write digest 3 and include H3 sum nil at the end. That's the end to our step 3. We have SHA-256 here, but RipeMD will result in a shorter hash, and that's why we use RipeMD. On to our next step. There's 2 networks in blockchain. There's test network and main network. In the case of our main network, we have 0x00. We want to include this at the beginning of our RipeMD hash. We're going to add VD4, and that's our version byte. Then let's write make byte and make it 21 byte. Up here, we have 20 bytes for SHA-256, but we're adding 0x00, so 20 plus 1 is 21, and that's why we added 21 here. At the beginning of our VD4, we're going to add 0x00. The hexadecimal numeral is 0, and we added 1 byte's worth. Then we're going to copy and write VD4. We're going to move on to our next byte, which is the position after 0x00. So we're going to include digest 3, and then we'll have 0x00 as our lead and have 21 bytes, in other words, our VD4. Now on to our next step, which is 5. We'll take the result from step 4 and perform SHA-256. We'll include new, and then again write. We'll include VD4, then digest 5, followed by H5 sum nil to create our hash. We'll need to repeat these steps again, so we'll include H6, then SHA-256, new. Then write digest 5. Our final line will be digest 6, followed by H6 sum nil. Now on to our next step. Our next step is saying to take the first 4 bytes in our hash for checksum. We'll start off with checksum, then digest 6. We'll take the first 4 bytes, so we've written 4. On to step 8. We want to make 25 bytes worth. This is saying to add the checksum after VD4. In other words, we're going to include the checksum after our digest. We'll write make, then byte, then 25, because we want to make 25 bytes worth. At the very beginning of our 21 bytes section, we're going to include our VD4. Then we're going to focus on what to attach at the end. We're going to add 4 checksum bytes, meaning 21 up to the end for checksum. And now on to our last step, which is step 9. We're going to add address and then encode base 58. And to do this, we're going to write DC8. Inside our wallet, we have blockchain address. Inside this, we're going to include the address that we just created, and that completes our blockchain address. We want to be able to call this blockchain address, so in order to do that, I want to add a method here. We'll scroll down and remove some of the empty lines I created. At the very end here, we'll write func, then wallet, then blockchain address. We'll return a string. Then we'll write return w blockchain address, and we're done. When we call on this blockchain address, we'll be able to return. If someone wants to rewrite this blockchain address, this is private, so that's not possible. That's what a method with this property can do. Now we want to call on this blockchain address and see what this will do. To do this, we'll go back to our main.go. Once we're back to main.go, we'll write fmt println followed by w blockchain address. When we run this, we see a short blockchain address displayed here. The original public key was this very long string. When we follow the address structure for Bitcoin, the final string that we created is this. This is a Bitcoin address. Please note, in my lecture, I'm not making the concepts and explanations specific to Bitcoin. So going forward too, I'll be referring to this string as a blockchain address. Now that we've gotten this far, let's move on to our next lecture.